This question says, using the reaction below, how many grams of water can form from each of the following? We have 2H2 plus O2 yields 2H2O. And in each case, we're given some number of moles or grams of oxygen or hydrogen, and we're asked for how many grams of water we can form. So if you haven't watched the previous question, it's probably a good idea to do that first. So here we start with 10.2 moles of oxygen. There's no way to directly convert from moles of oxygen to grams of water. So you have to do it in multiple steps. Specifically, for a plan of attack, we want to convert from moles of O2 oxygen to moles of water, and then to grams of water. So we want to do it in 2 steps. Starting with 10.2 moles of oxygen times. To convert from moles of oxygen to moles of water, or moles of anything to moles of something else, you need a balanced chemical equation that contains those 2 things. In this case, this equation is balanced and it contains oxygen and water. Since we want moles of oxygen to cancel, we want to put the 1 mole of oxygen on the bottom. The stoichiometric coefficient is 1. For every 1 mole of oxygen, the reaction says we'll make 2 moles of water. So we want to put the 2 moles of water on the top. Next, we want to convert from moles of water to grams of water. To convert from grams to moles, we use the molar mass because that's grams per mole. So 2 hydrogens is 1.01 times 2, or 2.02, plus 16, which gives us 18.02 grams of water is 1 mole of water. Note that molar masses are grams per 1 mole. It has nothing to do with the stoichiometric coefficient. You use the stoichiometric coefficients, the things in the front, when you're converting from moles to moles. You do not use them when you're converting from grams to moles. For grams to moles, it's always 1 mole on the bottom. All right, to solve this, multiply by the top, divide by the bottom, multiply by the top, divide by the bottom, and we find that there are 368 grams of water that would be formed from our 10.2 moles of oxygen. Let's look at the next one. We have 2.7 moles of hydrogen. In this case, we want to do something similar by way of a plan of attack. We want to convert from moles of hydrogen to moles of water, and then finally to grams of water, because all the questions are asking for how many grams of water. So starting with 2.70 moles of H2 times. To convert from moles of hydrogen to moles of water, we want to use our balanced chemical equation. It's 2 to 2. So we want to put our 2 moles of hydrogen on the bottom and our 2 moles of water on the top. Sometimes I'll have students ask me, well, if it's 2 to 2, you don't really need to do it. Yeah, that's true, but it does make it easy to watch or to see how you cancel out units, and it gives you good practice for writing this out, because a lot of times it's not 2 to 2 or 1 to 1 or 3 to 3. All right, now we want to convert from moles of water to grams of water. Just like before, we're going to use the molar mass. So we put the 1 mole of the water on the bottom and the 18.02 grams of the water on top. Multiply by the top, divide by the bottom, 3 sig figs, and when we do that, we get 48.7 grams of H2O. All right, last one. We're starting with 9.81 grams of oxygen. So in the previous 2 examples, we started with moles of hydrogen and oxygen. Now we're starting with grams of hydrogen or oxygen. So in this case, oxygen. So to convert from grams of one thing to grams of another, there's no direct conversion. In fact, this actually adds a step, because before we can convert from moles of oxygen to moles of water, we need to convert the grams of oxygen to moles of oxygen. So what we want to do is we want to convert from grams of oxygen to moles of oxygen, and then it's just the same as before. Then once we have moles of oxygen, we can convert that to moles of water, and then finally to grams of water. And this is very common, grams to moles to moles to grams. Because the mole to mole uses a balanced chemical equation. So if you want to go from one thing to another, you have to have those 2 moles next to each other in the middle in order to go from moles of one thing to moles of another. There's no good way to go from grams of one thing to grams of another, so it adds extra steps. So grams to moles to moles to grams. So if we start here with our 9.81 grams of oxygen times. The common mistake is people will put oxygen having a molar mass of 16. Don't forget that oxygen is O2, so its molar mass is 16 times 2, which is 32.00 grams of oxygen on the bottom. On top, we have 1 mole of oxygen. Now we're converting from moles of oxygen to moles of water. Always, to convert from moles of one thing to moles of another, we're going to use the stoichiometric coefficients. Here we want oxygen to go, so we put the 1 mole of oxygen on the bottom. And we want to end up with moles of water, so we put the 2 moles of water on the top. Then we want to convert from moles of water to grams of water, which we've already done twice. So we put the mole of water on the bottom and the 18.02, the molar mass of water, on the top. Multiply by the top, divide by the bottom, repeat until the end. And when you get done for this one, you'll find to 3 sig figs that you'll make 11 grams of water with all 9.81 grams of oxygen.